So to give you an idea of what confidence intervals are, think of it this way. Have you ever heard someone say, I'm 95% sure that such and such is true? That kind of thing. Well, that's what a confidence interval is. It's a percentage that a industry or a something has come up with that says this is the where we're saying we're going to be testing at. We're going to say that it has to be at least here, otherwise it fails. Okay? And we have confidence up to this point. Anything above it's great. Anything below it, we won't certify. So that's what industries use when they're trying to determine what their warranties are going to be. Because what they're trying to decide is what's the range of acceptability, that if it's within this range, then we think it should continue to work for its lifetime, which whatever we're determining the lifetime is. But if it gets outside of that range, then if it happens to be lower than the range that we're accepting, not 95% as an example, then what it really is that's when the warranty would pay. But if it's above that, then that means that we will have to pay even less than we originally expected. So that's what it's doing. And it helps us to determine our margin of error. So over the last several months, we've had the elections going on, right? And if you watch the news, they would say, here's poll information, and it would say that Biden was at a certain percentage and Trump is at a certain percentage. And then if you looked at the very bottom, right up underneath it, it always would say a plus or minus number, usually about 3%. That 3% is the margin of error, which was found by using confidence intervals, saying that they believe that the information is accurate, and then there's a plus or minus allowance of error within 3%. If the difference between the two candidates was less than 3% apart, then what it really means is that there isn't a difference between them. That the data is pretty useless. Okay, so that's one way you can tell whether or not they're telling what you want to hear. Okay, so a couple of things that we need to look at, and these are very important pieces of information to know. Point estimate. A point estimate is a single value estimate for the population parameter. The most unbiased point estimate of the population mean is the sample mean. What that means is, if we're looking at an entire population, say the entire United States, it would be impossible to interview every single registered voter in the United States. You would miss people if you tried calling them. You'd miss people that don't have phone numbers. You'd miss people that don't answer their phone when they don't recognize the phone number. You would miss all kinds of different possibilities. So you would have to pick a sample of them. We've talked about that in the past. The most accurate way to estimate what's going on in a population is to do the sample and then take the mean, standard deviation, etc. of the sample, and then we make inferences to the population. So let's say we had this group of we wanted to do the following is a random sample of followers from Instagram for 30 followers. There is there used to be. I don't know if Instagram even exists anymore, but to be honest with you, I have no idea. What? Is it the greatest or the worst? Okay, so there's way more, or there was way more than 30 users of Instagram. So the point estimate of we want to find the point estimate. So first of all, for population mean, which means we are using the sample we have, and we're going to find the mean. We already know that equation because we've used it in the past. It's the sum of all your x's divided by n. And that would give us our sample mean. If we use our calculator, we would go to number 4 on our calculator, which is list and spreadsheet. We would put in our X at the top, put in our data as a list, and push menu 411, and that would give us our X bar. So It's kind of stuff that we've done way back at the beginning of the year, about, I don't know, October-ish. So the point estimate for the mean number of followers of all users is 198, okay? And rounding to a whole number simply because all of our data was all whole numbers. If you don't round to that whole numbers, just make sure you would want, it's really important to tell is approximately 197.5, which rounds to 198. So you want to make sure that you are very clear on that. We don't really ever use the equal sign and after we start doing math. Okay, so math terms. Interval estimate is a interval or range of values used to estimate the population parameter. So just like we don't ever say equals, we always say it's within a margin of around that parameter. So we know the point estimate for mean is 198, but that's giving us a area to start looking around it, okay? And we use the level of confidence to determine what is that distance around, plus or minus what, 198 plus or minus what. So level of confidence is the probability that the interval estimate contains the population parameter. So once we have a population estimate, we have to say within a percentage that we believe that that actually does belong in the and is a good estimate for the population. Critical values are values that separate the sample statistics that are probable from those that are improbable. So we're going to talk about that. That's the distance. That's actually telling us whether or not it belongs or does not belong. Critical values, the way we would write those is like Z sub C or T sub C. That's the what you would see in terms of what they are representing as we're doing this. Okay. Whenever you were hearing about the Pfizer and the Moderna, I think is what it's called, the shots for the vaccines, you hear that there are 95%, 99%. That's what they're actually talking about, is this level of confidence. They're actually saying that they're in that 95% range, which is for the medical industry where they want things to be. For the general public, it sounds really good. But when it comes to the FDA, when the FDA was deciding whether or not this would be acceptable to put on the market, that was their standard that they were looking for. If it had been anything below that, then it wouldn't have gotten passed, which is one reason why I believe Pfizer went back after Moderna came out with their numbers and reevaluated to make sure that they were right up there at the same level, because they were coming out before them in terms of the FDA, and they wanted to make sure the FDA would approve them. A little bit of information that most people don't know because they don't know anything about statistics. So if you memorize these, you don't have to do this work. But if you have a level of confidence, if one pops up, which by the way in the assignment there's a couple of them that will pop up, that is not in this small little list, what you're going to do is take 1 minus the confidence level. So say it's 75% as an example. You do 1 minus 0.75, which is 0.25, divide by 2. Then you go into your chart, you'd look up that number to figure out what your Z sub Z is. Okay? All right, so next we're going to look at the margin of error. So once you find your Z sub Z, we use that in the formula for margin of error. It is the confidence level, critical value, which is this. This is the critical value. That's what the C sub Z is. The critical value times the standard deviation divided by the square root of n. Or if it's population, if it's sample, it's S divided. It's the same thing. But just remember that when you actually find standard deviation, population standard deviation and sample standard deviation are not the same. They never will be. Sample standard deviation is always a little higher than population because it's allowing for a bigger margin of error option. Okay, so let's say we have the same problem that we were looking at a minute ago. You have the same data, you put it into your calculator, you did menu 411, X bar, which is 197.53, and then S, which is 53, okay, which was found on the calculator. And then it says we want it at a 95 percentile, okay. Now, for right now, we're using the z-score. We haven't talked about the z-score, so it doesn't matter that the n is 30. Z-score can be used actually for any n, but for future reference, there are specific times when you would use the t-score, but we're only using z-score. So if you go back to the little chart at the top, at 0.95, it's at 1.96. So, like I said, if you memorize those, this first step is easy. You just go, oh, 95%, that's 1.96. What's your N and what's your S, and then you just plug those three numbers into the formula, and that tells you your error. So, for the situation we're talking about with the Instagram users, it's going to be 198 is the population parameter, is the point estimate, plus or minus 18.97 or 19. That's a 95 percentile. So at 95 percentile confidence interval, there's a margin of error of E, and the next thing we would say is at 95%, the population mean is between 198 plus or minus 19, which you'd actually do the math for that part, is between those two numbers. So the population mean would be in that, inside that boundary level. Okay? And this would be the way you would finish out your information, your statements. Or at a confidence level of 95%, the population mean is between 198 and plus or minus 19. Okay? Okay. Okay, so a confidence interval is the X bar minus the S, so the mean, sample mean, parameter, the population, point estimate, however you want to remember how to say that. Remember that the X bar is the point estimate minus the error, is around where the population mean is, and then point estimate plus the error. So point estimate plus or minus the error is where your mean population would end up being. And now this actually applies also to other types of point estimates. So population, anything you're talking about when you're talking about population mean, a point estimate is X bar. Population proportion, which we're going to see later in this unit, the point estimate is called P hat. Population variance, the point estimate is sample variance. Population standard deviation, the point estimate is sample standard deviation. So the things that go together in terms of names and what they're representing, that's what the point estimate is. So they always go together. But and then the error is always found by using that one formula. That one won't ever change. So we have C is 0.9. That's how you would see it on a paper. C is 0.9. That means a confidence interval of 90%. And using our handy dandy little chart, 90.9 is at 1.645. X bar is 12.3, S is 1.5, and N is 50. So we just plug it into the formula. ZC times S over square root of N. And that gives us our error. And then we're doing X bar minus the error and X bar plus the error to figure out what our confidence interval is. Okay? So go ahead and for a couple of minutes, go ahead and do the second example. And just remember that in terms of the error equation, the population sample is equivalent in basically to the sample, so it's the same formula. E is ZC of population over the square root of n. Okay, so y'all do that, and then we'll check our answer here in a minute. Well, if we want a specific confidence level, how many of our product, what sample size do I need to pull so that I can determine what that warranty would be? Okay, so that's a slightly different equation. It's the critical value, Z sub C, times the standard deviation divided by the error. So if we know we want a plus or minus error of 7, okay, and we know that in years past we have evidence of our variance being 53, and we want a confidence level of 95%, how many televisions do we need to pull off of our production line, randomly pull off our production line so that we can test them to make sure that we are working at a 95% level where our margin of error is going to be a plus or minus 7 months or 7 years or 7 whatever units that they're trying to do. So that's the next step. So sometimes instead of just using this to determine the warranty, it also requires figuring out, well, what size sample do I need to do so that I can achieve what I'm desiring. And that's what this science problem, this equation is for. It's figuring out what should I use as my sample so that when I do have a final determination and then broadcast to all of the consumers that that we're going to be where we want to be. Okay? Now, it is important that if you do not know the population standard deviation, you can estimate using the S as long as you have at least 30 members. Okay, so N has to be at least 30 to be able to use standard deviation sample to estimate standard deviation for population. If your N, after you do all of this calculation, is less than 30, then you have to know that standard deviation. You have to know the original population standard deviation. It does not work otherwise. The math will work, but it's irrelevant. Let me put it that way. Your results will be irrelevant. And kind of good rule of thumb, always, the bigger the N, the better it is, right? The bigger your sample is, the more accurate your explanation about your population will always be. But minimum of 30. Otherwise, that's when we use the t-score. That's why we have two different charts. Because if it's not over 30, you can't really use the z-score. All right. All right. Are y'all finished? Are y'all wanting to keep going, or are we good for today? That's a lot of information. That is 6-1, all of the notes for 6-1.